In this video, we're going to look at properties of definite integrals. And I thought at the very beginning, I would show them all to you right away. So feel free to pause the video, write them down, read them over. These are properties that we're going to be working with in calculus to help us solve a number of integral problems. So as I scroll down, feel free to look them over, read them, and what I'd like to do is actually apply them in a series of examples to show you how the properties work. Let's take a look at a couple right now. Oftentimes with these properties, you're going to have a collection of given statements. So here are some examples where we're going to use properties to try to answer questions involving definite integrals. But they give us some given statements right here. And the given statements are telling us that the value of 1, 2, and 3 definite integrals are respectively 5, -2, and 7. And then one other piece of info here, assume that function f is even. So based on those 4 given statements, it's now our task to come up with the solutions, if possible, to the integrals that we see here listed. So let's give it a try. In letter A, we have the integral from 4 to 1 of f of x. Let's switch the bounds and write that as the integral of 1 to 4, since I like when my lower bound is on the bottom and the upper bound is on the top. But one of the properties of integration is when you swap the bounds in that manner, we actually negate the value of the integral. So you have to make it negative. Now I know from the given statements that the integral from 1 to 4 of f is -2, but the outside negative will negate that. So I have essentially the opposite of -2, or a final answer of 2. Let's look at letter B, the integral from -1 to 4 of f. Well, I see that f from -1 to 1 is a given statement, so -1 to 1 of f of x. That's listed right there. And then I could add to that the integral from 1 to 4 of f of x dx. So what I've essentially done is I have the area in a first interval, added that to the area in the second interval, and so together that will equal the sum of both areas from -1 to 4. And I chose that strategic breakdown because of the given information. I can write down that the integral from -1 to 1 of f of x is equal to 5. So this integral is 5 plus the integral from 1 to 4 of f is given as -2, so that value will be a value of +3. Again, using properties of integration. Next one, letter C. So remember that the integral of a sum can be written as the sum of 2 integrals, and a constant can be pulled outside of the integral as well. So if I try to break down this collection, here's what I'd have. I'll have 2 times the integral from -1 to 1 of f plus the integral, actually 3 is a constant as well, so plus 3 times the integral from -1 to 1 of h. So let's see if we have enough information to answer that question. The integral from -1 to 1 of f is given as 5. So I have a 2 times 5, and then plus 3. Do we know what the integral from -1 to 1 is of h? Yes, we do. It's equal to 7. So my final answer will be, looks like 10 plus 21. So solution for letter C is 31. Now, letter D says, what is the integral from 0 to 1 of f? And that's not one of our givens, but I do know that f is an even function, and across symmetric bounds, the integral of f is equal to 5. But if f is even, then that's actually twice the value of the integral from 0 to 1. So if from -1 to 1 across f is 5, and I know f is even, then 0 to 1 would be exactly half of that 5. So this one here will be equal to 2.5, and I'll just write myself a note. I know that because f is even, because the integral from -1 to 1 of f is equal to 5, and we know that f is even. So doing really well so far. Letter E says, what is the integral from -2 to 2 of h? And unfortunately, I don't know too much about h aside from this integral statement here, but I don't know if it's even or odd. So h across these symmetric limits, I really don't know. So I'm going to have to just say this is unknown. I'm unable to solve this problem with the givens that I was presented with. And then letter F, finally here. Again, I can write that as the sum of two integrals. So that's the same thing as the integral from -1 to 4 of f plus the integral from -1 to 4 of h. And I know that integral from -1 to 4 of f is equal to 3, but I don't believe we know this integral here about h. Again, the only integral I know is from -1 to 1. So again, I'm kind of stuck right here. I don't know anything about that. So I've got to say overall, this is another unknown. I have no way of solving that series of integration. So that's kind of how the properties work. And I actually have a series of a few more examples that I'd like to show you in this video that I'd like you to try. They're a little bit more complex. So let's see if we can answer these questions. Again, a series of given statements and then some integrals to answer regarding those given statements. Feel free to pause the video right now, see if you can answer those 3 questions, I guess 4 questions, and then I'll walk you through the solutions in just a moment. Okay, let's begin. So this first example is, it's numbered as number 14. We know that f is an odd function. So let's see what we can do here. The integral from 0 to 3 is given as 8. And then the integral from 2 to 3 is given as 2. I'm looking for the integral from -2 to 0. Well, let's see here. If I know from 0 to 3 is 8, and from 2 to 3 is 2, then I can conclude that the integral from 0 to 2 would have to be 8 minus 6. So I can make this claim. And let's see here, if I know that f is an odd function, and from 0 to 2, the value of that integral is 6, then from -2 to 0, again across the metric limits, I must have a value of -6. Because what must be true if f is an odd function, then the integral across symmetric limits of any odd function has to equal 0. So if from 0 to 2, I know that's +6, then from -2 to 0 must be -6. So more challenging than the other ones we saw. Let's try 15. So here's another example where I might want to switch the bounds. It looks like these bounds are backwards. So for starters, with this first given statement, I'm going to write that as the integral from -2 to 4 of g of x. And if the original was given as -3, I have to negate this to make it equal to +3. And so let's see what I can figure out here. I'm looking for the integral from 4 to 6. I have the integral from -2 to 6 and then from -2 to 4. Well, essentially, the integral from -2 to 4 of my function plus the integral from 4 to 6 of the function would add up to be the area from -2 all the way to 6. So let's see what we know here. From -2 to 4, we established that that was equal to 3. From 4 to 6, I don't know what it is. That's my question. So I'll call that an unknown, maybe a variable x. And then from -2 to 6, the entire region is actually equal to 1. So the integral in question is this unknown right here. But if I know 3 plus that unknown has to add up to 1, well, that means my value from 4 to 6 has to equal -2. And then finally, number 16, only one given statement, and I'm tasked with trying to figure out 2 different integrals here. Let's see what we can do. So they're telling me that the integral from -2 to 5 of h is equal to +5. Find the integral of 0 to 7 of h of x minus 2. Well, remember that with function transformations, this is actually a horizontal shift. It's a horizontal shift to the right by 2 units. And if you notice, the bounds were equally shifted to the right by 2 units. My originals were -2 to 5, but these bounds are 0 to 7. The bounds were also shifted, and that's good, also shifted right by 2. So essentially I'm taking my area and just sliding it over on the coordinate plane. There's no change in the area. So this answer is going to remain 5. Now, to conclude, let's look at this last part here. I'm going to write this integral with the constant of 2 on the outside times -2 to 5 of h plus the integral from -2 to 5 of 1 dx. So the integral of a sum is the same thing as the sum of 2 integrals. Let's see if I can put some pieces together here now. The integral from -2 to 5 of h was given as 5. So here now I have 2 times 5 plus, now the antiderivative of 1 is simply going to be x. And if I use FTC on this, I'll have this to be equal to 5 minus -2. So I have 10 plus 5 plus 2, which is 7. And my final answer for that integral will be 17. So I hope you had success with applying those properties. They're tricky, they're challenging, and you've got to try to see them in action and take a look at the nuances that are presented. But practice them and take a look at the list of properties and see if you can apply them from given statements. Good luck in your practice, and I hope this video was helpful to you today.